is also a handle, and that is replaced by F is replaced by C. Reverse lo chestunam ante. We are doing reverse. So in place of F, you return T. Okay. And next T star, and ID, again ID is a handle. T is not a handle. Why? Because T after T star is there. T star is there. So T star ekkada means T place లో ఈ రాయడానికి లేదు. ఈ రాసాం అనుకోండి, ఈ తర్వాత ప్లస్ వస్తుంది. బట్ హియర్ ఈ తర్వాత మనకి ప్లస్ ఉంది, బట్ ఇక్కడ మన పర్టికులర్ ఇన్పుట్ స్ట్రింగ్ లో స్టార్ ఉంది. కాబట్టి నీ నాట్ టు రైట్ T in place of TE. No need to write that one. So మన ఇప్పుడు టాప్ డౌన్ పార్ట్స్ యూజ్ చేసినప్పుడు కెన్ స్టార్ట్ విత్ ద స్టార్టింగ్ సింబల్. Based on the given input you are apply a particular production. Same thing ఇక్కడ కూడా can use tools, and ఏది హ్యాండిల్ గా కన్స్ట్రక్ట్ చేయాలనేది you have to construct it. You have to identify. Okay. And ఇక్కడ T ని E గా రాయడానికి లేదు. Why? Because whenever you write E స్టార్ అయిపోతుంది, E స్టార్ ID అవుతుంది. But E స్టార్ ID not available in the production. So don't write it. And next go for the next handle to find the next handle. Here the next handle is ID. Next handle is ID. ID is occurred at right side. Okay. In ID place you can write F. And that ID place you can write F. So T star F. So totally you consider T star F. T star F is a handle that occur at right side. So that is replaced by a C. That is, sorry, actually it is T not F. That is T. Okay. In T star F you write T. And next in place of T it is actually T not F. It is T. In place of T, and it is a handle. Again you write it as E. So T. So T is also a production. In place of T you write T. So at last, for a given input string you have generated the starting symbol E. Is nothing but it is a bottom up parser. Leaves me. T star F. Not so consider that is handle. So you can find out the handle. Not only single one. Not consider a single one. You consider based on given production. Based on that given production, so you consider that handle. Not only single one. You consider number of characters, number of symbols, and you can find out the handle. Every time you can check it where you get the handle. Here ma T star F. So T star ID, right? In place of ID written T, and T star in place of ID written F. So T star F, you get T star F. So T star F is a production. Is there in the grammar? T star F is there in the grammar, right? T star F is a production. So it is considered as a handle. That is nothing but handle. In that place of handle you return T. It is not F, it is T. That is T. And in place of T is also handle, and in place of T you return E. So at last you are finding the starting symbol. And check it, just E place lo T rasnam, T place lo T star F, and F place lo ID, and T place lo F, and F place lo ID. So just check it, it is a leftmost derivation. Every time left, in each step you are replacing the leftmost non-terminal. So that's why you are calling it as rightmost derivation in reverse. Actually it is rightmost derivation, but you are starting with leaves to root right, and then reverse answer. Rightmost derivation in reverse. Okay, and using this input thing you are generating starting symbol E. Reverse. Okay, this is nothing but bottom up parsing. Okay, and this bottom up parsing is also called it as shift reduce parsing. Shift reduce parsing. So the shift reduce parsing uses some actions or operations, that is shift and reduce. Shift means you can shift the symbols into the stack, and whenever you can get a handle on the top of the stack, you can reduce it to the rightmost symbol. That's why we are calling it shift reduce. Okay, so actually you can take to implement this, use stack and input string. I will explain that. So shift reduce parts are the general idea to shift some symbols of input to the stack until a reduction can be applied. So you can use to parse a given input string, use input string and a stack. Directly you can take input string and a stack, and every time you can shift the input symbols into the stack. So just to shift cheskunte veltadi. That is nothing but shift operation. Whenever you can get a handle, a reduction cheyagalamu a particular inputs handle undanukondi, on top of the stack can get a handle means that is replaced by leftmost symbol. That is nothing but reduction. Reduction is nothing but whenever you can get a handle on the top of the stack, that is reduced to the leftmost symbol in a grammar production is nothing but reduction. Shift, reduction. Shift and so shift may shift ala shift cheskuntane veltam. Whenever you can get a handle, you can shift the symbols into the stack. I will show one with one example. Okay, the general idea of shift some symbols of input to the stack until a reduction can be applied. Reduction is nothing but whenever you can get the production form, rightmost production వచ్చింది అనుకోండి, that is reduced by the leftmost non-terminal. At each reduction step, a specific substring matches the body of a production, that is right side production, is replaced by the non-terminal at the head of the production. Head means left side non-terminal will be replaced. Okay. The key decision is during bottom-up parsing are about when to reduce and when to shift. So how to first identify that eppudu reduce cheyala and eppudu shift cheyala is how to find. That is the main task here. That is the main key decision for bottom-up parser. Okay. That is actually this reduction is a reverse of a step in a derivation, rightmost derivation in reverse. Okay. So actually this is a thing. Actually you can start in reverse. Actually you can perform this operation in reverse. You can start with id star id, so that becomes f star id, that becomes c star id, that becomes c star f, id is replaced by f, and t star f is replaced by t, t is replaced by e. So reverse, think reverse. Actually you know this process, but you can start from here and you can find out the starting symbol. Okay, handle pruning. What is meant by handle pruning? So whenever you can get a handle, that is replaced by the leftmost derivation, leftmost symbol. Okay, so handle is a substring, any substring in the given string. It matches the body of a production and whose reduction represents one step along the reverse of the rightmost derivation. So handle pruning is nothing but it describes the process of identifying the handle. The main thing is to identify the handle. So whenever you can get a handle, that is replaced by the leftmost non-terminal. So reducing them to the appropriate leftmost non-terminal. So it is the basis for, it is the main basis for bottom-up parsing, and handle pruning is achieved by the rightmost derivation in reverse. So handles paina you can substitute cheskunte veltam kada. This process you can call it as handle pruning. This process to find at last the starting symbol is nothing but handle pruning. Handle is nothing but that particular specified production will get, and you can identify that handle, and that is replaced by the leftmost symbol. So again, this is the process. So every time in each step we are identifying the handle. The first time id is the handle, next time f is a handle, and next time id is a handle, next time t star f is a handle. Like that it is reduced to, this is reduced to e. At last it's starting symbol. You can get the starting symbol. Okay, and e process ela chestante can take stack and input. Initially stack is contain dollar and this input contain input string. W is nothing but given input string followed by the dollar symbol. And at last, and you can perform some shift and reduce operations here. So only you can perform shift and reduce operations. Okay, and shift the symbols whenever you can get a handle in the top of the stack, that is replaced by the non-terminal. Okay, and it is the last acceptance configuration, that is whenever stack content, that is dollar followed by a starting symbol. And ikkada complete input string is parts completely, it contain only dollar. So it is successful. The given input string is successfully parsed, means the given input is correct. The given input string is syntactically it is correct. Okay, so this is the initial state and is the last state, acceptance state of that input string. Okay, how it accepts, I will show like this. Stack content, and ikkada mana a table use cheyatledu, just I will consider stack and some inputs and just find out the handles, and handles place lo can consider the leftmost symbol. So initially stack content just that dollar symbol, input id star id, just perform shift operation. So these are the operations performed in this parser: shift operation, reduce operation, accept. At last ikkada starting symbol, ikkada dollar symbol undante it is accept stage, accept that one. So that is accept operation. And error, manaki ekkada handle dorkatledu means it isn't possible to get that particular production of the form, and it is not reached a starting symbol, so automatically can say that is it. So these are the actions. Actions are operations performed by the shift reduce part. Okay, so shift means the next input symbol is shifted onto the top of the stack. Just can shift the input symbols into the top of the stack. And reduce means replace the handle. Whenever you can get a handle in the top of the stack means that is replace the top of the stack by the non-terminal, left side non-terminal. Accept means successful completion of parsing. And error means parser discovers the syntax error and calls an error recovery routine. Means it's not possible to get a starting symbol for a given input string is nothing but you can getting a error. Okay, and this is the input. So first to perform shift operation, id will be shifted into the stack. Okay, and it is the top of the symbol, so can know that id is a handle. So can reduce, perform reduce operation, reduce by f tends to id. F tends to id is a production, so in place of id that is reduced to f. Okay, and id plus lo f better. And next reduce by, and again it is a handle, f is also handle, again you can reduce by using this production. So f is replaced by t. Okay, and next here t is not a handle here, so why? Because star is there. So next you can perform shift operation. Shift the symbol into the stack. Star and a shifter. T star. Again T star is not a handle. Again you can shift the next input symbol, that is id. id will be shifted. Here the top of the stack id contain it is a handle. id is a handle. So can reduce, perform reduce operation. F tends to id. And id is replaced by f. And again it's complete three symbols here is the top of the stack, and that become a handle. T star f is a handle, and that is replaced by t. Okay, again t is a handle, that is replaced by e. So at last you are getting in the stack input symbol, starting symbol, nothing but it is accept. This is shift reduce parser, performing only these four operations. Okay, shift, reduce, accept, and error. Same thing, it is one more example with this one, id plus id star id, and ikkada chudandi id tarvata plus vachindi kabatti definitely గా t is also reduced to e. T is also reduced to y, because whenever you write in place of it a star ఉన్నప్పుడు e రాసాం అనుకోండి, we are getting like this, e star id, but that handle is not there. So kabatti ikkadiki stop చేస్తున్నాం, and you can go move to the next input symbol and you can check that handle occur or not. Okay, id is replaced by f is replaced to t is replaced by e, and then e plus varke vachindi manaki. So not getting the handle, so can move on to the next input symbol, that is id. Again it is a handle, id is replaced by f. Okay, and f is replaced by t, and t star id. Okay, t star id, star undi kabatti no need to write in place of t e. Okay, and id is replaced by f, and top of the symbol, top of the stack it contains t star f is a handle, that is replaced by t, and the top of the stack e plus t is a handle, that is replaced by e. Okay, so at last we are getting the starting symbol means that is accepted. And just see in reverse, so it is nothing but it is a rightmost derivation. It performs rightmost derivation every time rightmost symbol is replaced. In each step rightmost symbol is replaced in reverse. This is called rightmost derivation in reverse order. This is one more example. This is the input string AAABB. Okay, AAABB ni ela chesaru chudandi ikkada. So AAABB last year based on the given productions based cheskoni, so ఏది modify చేస్తే మనకి correct production form వస్తుందో చూసుకొని దాన్ని replace చేస్తారు. So here A is also handle, but that is not replaced. A handle అవుతుంది, but it is not replaced. Why? Because if you starting with A means starting with A productions ఏం లేవు అక్కడ. AAA ఉంది కదా, so whenever that first A is considered as a handle, AAA రాసామనుకోండి, AAA is not possible. The production in that production C star F star no ma, different, same కాదు. So the sequence is different, right? Sequence మారిపోతుంది. ఓకే, సో ఇప్పుడు T ప్లేస్ లో మళ్ళీ ఇక్కడ మాడిఫై చేసే ఛాన్స్ ఉంది, ఇక్కడ ఏంటి ఇక్కడ మాడిఫై చేసే ఛాన్స్ ఉంటుంది, ఇక్కడ ఉండదు, కాబట్టి డిఫరెంట్ అవుతుంది, నాట్ సేమ్. ఓకే, సో ఇక్కడ ఫస్ట్ ఏ లోనే హ్యాండిల్ అనుకోండి సబ్స్టిట్యూట్ చేసామనుకోండి, సో ఇట్స్ నాట్ పాసిబుల్ టు గెట్ ఏ హ్యాండిల్, పర్ఫెక్ట్ హ్యాండిల్ వెన్ యూ రైట్ లైక్ దిస్. ఏతో స్టార్ట్ అయ్యే ప్రొడక్షన్ ఏం లేవు అక్కడ. ఓకే, కాబట్టి సో ఇక్కడ నెక్స్ట్ ఏకి వెళ్ళండి, అలా కూడా ట్రై చేయండి. నెక్స్ట్ ఏని సబ్స్టిట్యూట్ చేయండి, ఏ 2 B's రైట్. ఓకే, సో ఇలా రాసేసండి. సో నెక్స్ట్ ఏలో ఏ రాస్తాం, స్మాల్ ఏ, దట్ ఈస్ కన్సిడర్డ్ as హ్యాండిల్ and that A I written as capital A, AAABB. So try with all possibilities, not only single one, have to try all possible handles and try to get starting symbol. మనం సేమ్ స్టార్టింగ్ సింబల్ నుంచి ఇన్పుట్ స్ట్రింగ్ ఎలా జనరేట్ చేస్తున్నాం, బై ఏదో ఒక ప్రొడక్షన్. ఓకే, ఒక పర్ఫెక్ట్ ప్రొడక్షన్ విల్ బి అప్లైడ్ అండ్ హ్యావ్ టు ఫైండ్ ద కరెక్ట్ అవుట్పుట్, రైట్? సేమ్ థింగ్ ఇక్కడ కూడా హ్యావ్ టు ట్రై ఆల్ ద హ్యాండిల్స్. Try all the handles. If it not possible with one handle, okay, then మళ్ళీ సబ్స్టిట్యూట్ చేసేసి you can go for next one. Okay, ఇలా తీసుకున్నాం అనుకోండి. For example, I will not consider that one. I consider the second A is handle and that is replaced by this A is replaced by capital A. Okay, and next AA ఉంది కదా, A is also handle. AA is a handle and that is replaced by AAB. ఇది కూడా పాసిబుల్ అవుతుందా? It's not possible. You try all the handles. Direct గా ఎలా రాస్తారు అని అడగొచ్చు. So we have to try all the handles. Okay, it is also not possible, right? Second A. So can try for third A. Third A is replaced by capital A. Okay, it is considered as a handle and that small a is replaced by capital A. And again AA that AA is a handle, capital A, small a is a handle and that is replaced by capital A. And next ఇక్కడ ఏం చేశారు, small b is considered as capital B రాసేస్తారు. So that is in the form of this one, starting symbol derived production వచ్చేసింది, ఆ ప్రొడక్షన్ ఫార్మ్ లోకి తీసుకొచ్చారు. So I had to try that, ఆ ప్రొడక్షన్ ఫార్మ్ లో వచ్చేలాగా I had to try it and that is replaced by the starting. Like that you can derive the కంపల్సరీగా మనకి స్టార్టింగ్ సింబల్ రావాలి, ఎలాగోలాగా హ్యావ్ టు ట్రై టు గెట్ దట్ స్టార్టింగ్ సింబల్ అండ్ ఏ పర్టికులర్ ప్రొడక్షన్ పైన మేము రిడక్షన్ చేయాలనేది హ్యావ్ టు ఫైండ్ విచ్ వన్ హ్యావ్ టు రిడక్ట్ ఇన్ టు ద లెఫ్ట్ మోస్ట్ సింబల్ హ్యావ్ టు రైట్. ఇస్ ఇట్ క్లియర్? This is another example with stack implementation of shift reduce parser. Stack content input and what are the actions? Here the actions are shift reduce and accept. Definitely it is accepted, accept వస్తుంది. So different గా తీసుకున్నాం అనుకోండి, it is a wrong input తీసుకున్నాం అనుకోండి, definitely it gives error. Okay, and these are the steps is defined. This is the first step, second step and this is the third step. Like that ఏ పర్టికులర్ హ్యాండిల్స్ ఇక్కడ కన్సిడర్ చేస్తా ఉన్నది, దట్ ఈస్ షోన్ ఇన్ ద పార్ట్. ఓకే, దిస్ ఇస్ ద షిఫ్ట్ రెడ్యూస్ పార్ట్స్, యాక్షన్స్ పర్ఫార్మ్డ్ బై షిఫ్ట్. సో ఒక ఎగ్జాంపుల్ తో ఎక్స్ప్లెయిన్ చేయాలంటే యూ కెన్ జస్ట్ ఎక్స్ప్లెయిన్ విత్ అన్ ఎగ్జాంపుల్. సో వాట్ ఆర్ ద ఆపరేషన్స్ పర్ఫార్మ్డ్ బై దట్ షిఫ్ట్ రెడ్యూస్ పార్ట్స్? and explain with example. So these are the 3 topics from this unit. Okay. Okay, up to here ikkadi varaku chadukondi. For mid to read up to this slide. Okay, 3 topics from this third unit. What is bottom up parsing? Shift reduce parser with an example. Handle pruning. What is handle pruning? And maybe they ask what is the difference between bottom up parsing and top down parsing. I written that one also. Just go. Okay. సో ఇప్పుడు మీ ప్రాబ్లమ్స్ అవి అయిపోతే ఇంకా తీసుకోను, లేదంటే తీసుకుంటాను. అదే చెప్తామని నా వల్ల కూడా కాదు. It is very simple to construct top down parsing and it's somewhat difficult to construct the parsing, but it is bottom up parser is used for larger programs and only small set of programs కి మాత్రమే అప్లై చేస్తాం, అండ్ ఇది వచ్చేసి లార్జ్ సెట్ ఆఫ్ ప్రోగ్రామ్స్ కి అప్లై చేస్తాం. And error correction వచ్చేసి error detection is very weak using top down parsing, and it is very strong, and it is also identify the what type of errors it occurs. It easily find using bottom up parsing, but it is very difficult to construct and it is very easy to construct. So it is not applicable to ambiguous grammar. So definitely గా left recursion అవన్నీ eliminate చేయాలి, but ఇక్కడ అదంతా అవసరం లేదు. It accepts ambiguous grammar. So దీంట్లో different types of రాయండి. recursive descent parser and predictive parser. Predictive parser అన్న LL1 parser అన్న same. Those two are same. And ikkada so many parser techniques are there. Operator precedent parser, LR parser, LLR, CLR. So many parsers are there. And we just write shift reduce parsers and operator precedent parser. Okay. And this parsing technique is leftmost derivation, and this rightmost derivation in reverse. Okay. ఈ 3 టాపిక్స్ చదువుకోండి మా. థర్డ్ యూనిట్ లో షిఫ్ట్ రెడ్యూస్ పార్సర్ విత్ ఎగ్జాంపుల్. What are the actions performed by shift reduce parsers, and the difference between top down parsing and bottom up parsing. What is bottom up parsing and what is handle pruning? Actually, for this example, NFA with null construct చేశారు కదా, and it contains so many null productions. It contains so many null productions, right? Null transitions. It contains so many null transitions, and null transitions నుంచి NFA construct చేయాలంటే కూడా easy, but it contains so many transitions. Definitely గా చాలా transitions ఉంటాయి. అలా కాకుండా డైరెక్ట్ గా దీన్ని NFA లోకి కన్స్ట్రక్ట్ చేయండి. ఇట్స్ బెటర్. మీరు రాసింది అది కరెక్టే, దట్ ఈస్ కరెక్ట్, బట్ అంత కాంప్లికేటెడ్ కన్స్ట్రక్షన్ మనకు అవసరం లేదు. డైరెక్ట్ గా NFA అడిగితే డైరెక్ట్ గా రైట్ NFA. సో దే మే ఆస్క్ NFA విత్ నల్ ట్రాన్స్ఫర్ NFA, అండ్ ఏది స్పెసిఫై చేయలేదనుకోండి NFA విత్ నల్ ట్రాన్స్ఫర్ ఫైండ్ అవుట్ చేయండి. అండ్ స్పెసిఫిక్ గా NFA అన్నారంటే యూ మస్ట్ ట్రై టు డైరెక్ట్లీ కన్వర్ట్ ఇంటూ NFA. And you can easily understand from this example, it is ending with ABB. It is a regular expression. It accepts the string with any number of A's and B's followed by ending with ABB. So directly write it as any number of A's and B's followed by A, B, B. This is enough. And from this NFA we can easily find out DFA. DFA ఏమొస్తుంది ఆల్రెడీ ఇక్కడ A ఉంది కాబట్టి B వస్తుంది and ఇక్కడ A and ikkada B and this is also on B and A. This is DFA. Okay, and DFA nunti regular expression. How to construct from DFA to regular expression? That is the procedure. Minimize kuda cheyochu. If possible to minimize kuda cheyochu. And so the regular expression is converted into NFA with null cheyochu. And NFA cheyochu and NFA to DFA, minimize DFA and minimize DFA to regular. లేదంటే డైరెక్ట్ గా కూడా రెగ్యులర్ ఎక్స్ప్రెషన్ టు NFA, రెగ్యులర్ ఎక్స్ప్రెషన్ టు DFA and DFA to regular expression. Conversion is a cycle form and you can convert it into a regular expression also. Okay, how to convert a DFA into regular expression? I want to show the procedure for this one. For example, first I start with a simple problem. What it accepts? Any number of zeros and ones. So this finite automata accepts any number of zeros and ones. I want to find out regular expression for the given finite automata. For this finite automata, I want to find out regular expression. How to find? So you can write the equations here. You have to write some equations. So what are the transitions into that state? What are the transitions into that state you consider? So for every state contain a equation. So I want to write equation for Q naught. So you can write like this: Q naught equal to. So what are the transitions into that state? On 0, on 1 altundi. So you can write it as Q naught 0, Q naught 1. Same state means Q naught on 0 it goes to the same state, Q naught on 1 it goes to the same state. So the equation, so what are the transition into that state? What are the transition into that state that you consider? A state నుండి వస్తుంది Q naught నుంచి Q naught కే వస్తుంది, Q naught on 0, Q naught, so Q naught 0 and Q naught on 1, so it goes to the same state, so Q naught 1. It coming from Q naught only, it's coming from Q naught ke ela vastundi, Q naught from Q naught only, so on 0, on 1. And it is a starting state. For starting state you must include null. Only for starting state you must include null, means epsilon. Okay, and this is the equation Q naught equal to Q naught into, and apply Adam's theorem. What is Adam's theorem? Q equal to R equal to Q plus RP means write it as QP star. The same symbol in Ankondi, the same symbol is here. So write as it is Q and this to the power of positive closure P star, QP star. So this is the form. So this is nothing but Adam's theorem. In place of Q plus RP, write it as QP star. Why? Because same symbol occurs here. You write like this. So our formula ni ikkada apply chestam. So this is nothing but R. Okay, this is nothing but null. Null is nothing but Q. R. So same symbol వచ్చింది కదా, Q naught. That is nothing but R. This is P. 0 plus 1 is P. 0 plus 1 is P. So how to write the formula? How to change its formula? QP star, right? QP star. Q means null. 0 plus 1 P star whole star. 0 plus 1 is P. P star means 0 plus 1 whole star. So null into epsilon into 0 plus 1 star is nothing but 0 plus 1 whole star. So this is nothing but it accepts this regular expression, any number of zeros and ones. Like that you have to write. So write the equation from equation for each state, and you have to find out regular expression in terms of final state. Ikkada enti Q naught is the initial state, Q naught is the final state, and you have to find Q naught only. You have to find Q naught only. So you are finding Q naught is 0 plus 1 whole star. Okay, let's see one more example. This is one more example. ప్రాక్టీస్ చేశారంటే ఇట్స్ వెరీ ఈజీ మా. ఎందుకు వస్తుంది నవ్వు? జీరో Q2 01. Yeah, here two final states are there. So you have to find the Q0 plus Q1. So the two final states you have to find the formula Q0 plus Q1 value find out cheyyali. So first of all, there are three states. So write first three equations: Q0 equation, Q1 equation, Q2 equation. Q0, what are the transition into the state you have to write. So for Q0 0, right? On Q0 goes to the same state. Q0 0 plus, and it is a starting state kabatti null kuda add cheyyali. Next for Q1, it is coming from Q0, right? Q0 on 1. So write Q0 1. So what are the transition into that state? Q1 on 0, it goes to the same state. Only into the state. So a transition to our state we consider that state only. Into the state that is on 0, it goes to the same state. To write it as Q0 0 plus null. And what are the transition? This is the one transition, and this is total two transition into this state, Q1 state. So e transition from Q0 1. So write Q0 1 plus, and e transition Q1 and so Q1 1. And write the formula for Q2. How many transition into the Q2? Three transitions coming into Q2. So write that Q1 0, Q2 0, Q2. Okay, these are the three equations. Manam find out cheyalsindante Q0 plus Q1. Q0 value kavali and Q1 value unte chalu, mana Q2 avasram ledhu. Okay, and ekkadana ikkada Q2 undanukondi, Q0 Q1 place lo you may use Q2 anukondi, compulsory Q2 ni kuda solve cheyalsi. But ikkada Q0 Q1, it doesn't use any Q2 here, so no need to solve Q2. You solve only Q0 Q1. Okay, first solve Q0. It is very easy. Why? Because null and a symbol in kabatti it is very easy to find and apply the Adam's theorem. That is R equal to Q plus QP star. Okay, so Q0 equal to, what is the formula? Epsilon 0 star. Epsilon into 0 star. So you are getting Q0, right? Q0 equal to epsilon 0 star means 0 star. Use that identity rules. Identity rules use chesi inka simplify cheyalanunte cheseyochu. Use that identity rules and simplify the regular expression. And use this Q0 value here. You can get Q1 value. So Q0 value into 0 star 1 plus Q1 1. Okay, it is also same as Adam's theorem. Definitely Adam's theorem formula ke teeskoni vastam. Okay, and apply the Adam's theorem. So after applying the Adam's theorem, what is the value? This is nothing but Q R P 0 star 1 star. Okay, you are getting the regular expression for Q0 Q1. Just add these two values, 0 star plus 0 star 1 star. A section, third year A section. Okay. So it accepting two final states are there. So it accepting either 0 star means any number of zeros followed by means 0, any number of zeros it accepts, or 1 followed by any number of 1. 1 followed by any number of 1. So for example, E final state anukondi, so any number of zeros followed by 1 followed by any number of 1. And only ఇది ఒకటే final state anukondi, so you can end with 0 star. So total it accepts that type of thing. Like that you have to convert from finite automata to regular expression. Is it clear? So same thing, just apply the Adam's theorem. Definitely Adam's theorem formula ki తీసుకురావాలి ఏదైనా సరే. సో మనకి ఇక్కడ పాసిబుల్ లేదనుకోండి, మేబీ యూ కెన్ యూజ్ సమ్ అదర్ స్టేట్ ఈక్వేషన్ సబ్స్టిట్యూట్ ఇంటూ అనదర్ ఈక్వేషన్. అట్లా సబ్స్టిట్యూట్ చేసుకుంటూ హ్యావ్ టు ఫైండ్ అవుట్, కెన్ రైట్ ఇన్ Adam's theorem formula అండ్ అప్లై ద Adam's theorem. ఈ Adam's theorem అప్లై చేస్తేనే మనకి పర్ఫెక్ట్ రెగ్యులర్ ఎక్స్ప్రెషన్ వస్తుంది. ఓకే, దిస్ ఈజ్ కన్వర్టింగ్ finite automata to regular expression. ఇది కూడా ఒక ఎగ్జాంపుల్. రైట్ ఆల్ ద ఈక్వేషన్స్ ఫస్ట్. Write all equations for this one, and here q naught is a starting state and final state. So q naught ఒకటి null add చేస్తాం, and you can write can find in terms of q naught only, and it is also a final state, so can find q naught value. Okay, so మనకి ఇవన్నీ సాల్వ్ చేయాల్సిన అవసరం లేదు, ఓన్లీ q naught ఫైండ్ అవుట్ చేయాలి. బట్ q naught లో you are using q1 q2, you must use q1 q2 formulas here, and you can find apply the regular Adam's theorem and find out the regular. And next ఏంటి, NFA to regular expression రాదు. It's somewhat very difficult. Definitely that is in DFA only it gets regular expression. So NFA ఇచ్చారంటే first convert it into DFA, and DFA నుంచి have to find out regular expression. It's somewhat difficult. Why? Because number of transitions ఉంటాయి కాబట్టి నెంబర్ ఆఫ్ టైమ్స్ రాయాల్సి ఉంటుంది. సో దాన్ని రెగ్యులర్ ఈక్వేషన్ రెగ్యులర్ ఎక్స్ప్రెషన్ లకు కన్వర్ట్ చేయాలంటే somewhat difficult. So compulsory it is DFA only. It's possible to get regular expression. ఏదైనా ప్రాబ్లం ఇస్తే మాత్రం ఇలా సింపుల్ గానే ఇస్తారు, ఒకటి రెండు నల్ ట్రాన్సిషన్స్ ఉంటాయి, అవన్నీ ఎక్కువ ఇస్తే మాత్రం ఇట్స్ సమ్వాట్ డిఫికల్ట్ టు కన్స్ట్రక్ట్. సో మెనీ ట్రాన్సిషన్స్ వస్తాయి. సో సేమ్ ప్రొసీజర్ ఇస్ సేమ్ ప్రొసీజర్, జస్ట్ యూజ్ ద ఫార్ములా extended transition function. You have to find out whenever a transition diagram contain null transitions, use this formula compulsory. You have to find out q naught on a transitions find out చేయాలంటే compulsory use this extended transition function. Is formula is E closure of delta of E closure of q naught comma a. This is the formula. First you have to find out E closure of q naught, means all null transitions on q naught, and then వచ్చిన వాటికి you can find number of states. On the number of states you can apply A, and then మళ్ళీ వచ్చిన వాటికి again apply E closure. So starting లో E closure apply చేయాలి, and at last E closure apply చేయాలి. Okay, definite గా ఇది null transitions ఉంటాయి. If the transition diagram contain null transitions, so ఒక పర్టికులర్ ట్రాన్సిషన్ చేయాలి అంటే ఏదైనా ఆన్ ఏ ఆన్ బి ఆర్ ఎనీ ఇన్పుట్ సింబల్ ట్రాన్సిషన్ చేయాలంటే యూ మస్ట్ యూజ్ దిస్ ఫార్ములా. Okay, first find out E closure of all null transition on q naught, and you are getting some state. On that state apply A, and again you are getting some state, again a state paina you can apply E closure. Okay, that is the formula. Okay, E closure of delta cap. This is nothing but E closure of q only. Okay, ఇది ఏంటంటే is nothing but E closure of q only, and that is applied on the input symbol x, and again apply the E closure. So delta cap of E comma q comma epsilon is nothing but E closure of q. ఇది ఇప్పుడు అర్థమైంది కదా. ఇప్పుడు క్యూ నాట్ ఇప్పుడు this is NFA with null most and you have to find out NFA without null most means write all the states in that transition and apply the input symbols on that state by using this formula. Not using directly apply Q naught on A కాకుండా use this formula and find out Q naught on A, Q naught on B, Q1 on A, Q1 on B, Q2 on A, Q2 on. Is it clear? And లేదు DFA construct చేయాలనుకోండి, I want to construct NFA with null to DFA. NFA with null to DFA. Starting state మాత్రం you consider only Q naught. Q naught on A, Q naught on B using this same formula you can write it. But DFA లో ఏంటంటే ఓన్లీ న్యూ స్టేట్స్ ఏవైతే న్యూ స్టేట్స్ వస్తాయి you can apply on new state only. అన్నిటి మీద అప్లై చేయము, you apply only the new state. And this process repeated until no more new states are exist. Okay, that is the process for DFA. But use this formula. If NFA null transitions are there, we must use this formula only, can find it. Is it clear? దీనికి DFA చేద్దాం మరి. This is NFA with null transition. I want to convert into DFA. B na. So this is NFA with null transitions. Null is there, epsilon is there. So this is NFA with null transition. So I have to find out DFA. I want to construct DFA for this given diagram. Okay. So starting state definitely we consider only starting state Q naught and apply that transition function. Find out Q naught on A. Find out Q naught on A first. Okay. Q naught on A means first find out E closure of Q naught. E closure of Q naught is Q naught. Q closure of Q naught is nothing but Q naught. So there is no null transition on Q naught. So first write E closure of every state. E closure of Q naught is Q naught only. E closure of Q1, Q1, Q2. E closure of Q2, Q2 itself. Q2 itself. Okay, null transition is nothing but without seeing anything, without scanning anything, it goes. We are changing the state. We are changing the state. Means you are at Q1 means you are at Q1 and also you are at Q2 also. Without seeing anything, you are at Q1 and also you are at Q2. Okay, these are the E closures of each state. Okay, only ikkada maatrame manaki E closure of Q1 contain Q1, Q2. Why? Because null transition, epsilon transition is there. Okay, so first find out Q naught on A. So is nothing but E closure of delta of E closure of A, Q comma A. This is the formula you can apply. So E closure of Q is nothing but Q itself. Q naught kada, Q naught itself. So Q naught comma A. So Q naught comma A is Q naught on A, it goes to the state Q1. So E closure of Q1, Q1, Q2. So Q naught on A is nothing but it goes to the state Q1, Q2. You are getting the new state here, Q1, Q2. And next apply on B. Just I will override here B. I written B here, just B. And E closure of Q naught is nothing but Q naught on B. Nothing is there. Q naught on B, no transition. No transition. So E closure of nothing means nothing. Okay, we are getting only one new state. So you can do again the transition on this state, Q1, Q2. Consider as a single state. Consider that is a single state. So then again you have to do the transitions using the same formula. Okay, instead of Q naught here, write Q naught, Q1. Two states. On A first. Sorry, Q1, Q2. Q1, Q2 is the state on A. Okay, so first find out Q1, Q2 E closures. Q1 E closures is Q1, Q2 and Q2 E closure is Q2. So Q1, Q2 only. Q1, Q2. So E closures also Q1, Q2 on A. So Q1 on A, no transitions. Q2 on A, no transitions. So there is no transitions on A. Okay, next on B cheyandi. On B, so just I change here B. Okay, so we are getting E closure of Q1, Q2, nothing but Q1, Q2 only. Q1 on B, no transition. Q2 on B, Q2. E closure of Q2, Q2 itself. So we are getting one more new state, Q2. Q1, Q2 on B, it goes to the state Q2. So we are getting one more new state, that is Q2. Again do transition on this Q2 state. Q2 on A. So here you write only Q2, Q2 on A. So first find out E closure of Q2. E closure of Q2 is Q2 itself. Q2 on A, no transition. So nothing is there on A. Next Q2 on B, Q2 on B. So E closure of Q2 is Q2 itself. Q2 on B is Q2. So E closure of Q2 again is Q2. And no more new states are generated, and stop here. These are the three states in DFA. And the final state is, whatever the final state in that year, Q2, these two are final. Wherever Q2 is that, those are final. That is the DFA construction. Main procedure and the same, but use that formula whenever E closures are there. I mean, transitions, null transitions are there, use that formula. That's all. So about first unit, and it tells kada 10 short answers questions and 5 questions. So 5 questions వచ్చేసి from first unit 2 questions, second unit 2 questions, and last third unit నుంచి 1 question వస్తుంది. Okay, and first unit of phases అవి చూసుకోండి. Phases of a compiler and difference between compiler and interpreter, and అన్ని conversions, NFA to DFA, regular expression, write a regular expression, DFA to minimization of DFA. These all conversions are very important. Okay, and first unit link regular expressions, DFA NFA difference enti, what is DFA, what are the tuples in DFA, what are the phases in DFA, phases in compiler, what is the cross compiler, like that you may ask. What is interpreter. Okay, and so from second unit context free grammar and enti, what is the part C, LMD, what is RMD, so many short answers, short questions. Okay, what is LL of 1 grammar, LL of 1 parser. Okay, what is predictive parser table, what is handle pruning, what are the actions performed in shift reduce parser. Okay, and second unit నుంచి అంటే ఇంకా recursive descent parser construct చేయమని, means you can write the program for every production అని, and maybe may ask LL of 1 parser table construct చేయమని. Parser table construct చేసి ఒక ఇన్పుట్ string ఇచ్చేసి పాస్ చేయమని. Okay, that is those are the questions. And lexical analyzer, what is the role of lexical analyzer, what is the role of what is that parser. Okay, and what is the lex program, what are the structure, what is the structure of lex program, like that they ask question. What is lex tool, what is the purpose of use of lex tool. Okay, ఇంకేమున్నాయి టాపిక్స్ ఫస్ట్ యూనిట్ లో ఇవే కదా ఉండేది. ఇంకా translators, compiler construction tools, what are the construction tools used in compiler. Chomsky hierarchy of languages kuda chuskondi ma. Chomsky hierarchy of languages and recognizes which grammar is recognized by which finite automata, which mission, and different types of grammars. What is the difference between each and every grammar? What is lexeme, what is token, what is pattern? So lexical analysis lo use the three terms: pattern, lexeme, token. I would choose input buffer. How to write the transient diagram for identifier, and what is the how to write the transient diagram for number ke transient diagram with integer part, fractional part, with exponent part, transient diagram, and representation. That representation is very important. Derivation trees, parts trees. Next, ambiguity. So grammar is you have to find out ambiguity. So this grammar this grammar is ambiguous or not. And take your own sentence or a string and try to find out, construct two parts tree. If you get two parts tree for a given sentence, it is, can say that ambiguous. And meere find out cheyala sentence enti anedi. Sentence ivvakapochu, just grammar ichesi this grammar is ambiguous or not ani adgochu. Okay, so I have to take one simple string and string ki two parts tree generate cheselaga construct cheyandi. This is nothing but it is ambiguous. Lexical generator, specification of token. That's all ma.
Regular expression to NFA solution final using null
using null సేమ్ ఉంటుంది మా, సేమే ఉంటుంది డెఫినెట్ గా, కానీ నెంబర్ ఆఫ్ ట్రాన్సిషన్స్ ఉంటాయి అంతే. రెడ్యూస్ చేయాలి అండ్ బెటర్ హ్యావ్ టు ట్రై లైక్ దిస్ ఓన్లీ. నేను ఇందాక చెప్పాను కదా, రైట్ ఫర్ ఎన్ఎఫ్ఏ ఫర్ గివెన్ రెగ్యులర్ ఎక్స్ప్రెషన్ అలా ఏం అడగరు. సో దే గివెన్ టేబుల్ ఇచ్చేసి కన్స్ట్రక్ట్ చేయమంటారు. లేదు అంటే ఒక టేబుల్ ఇచ్చేసి డిఎఫ్ఏ టేబుల్ కన్స్ట్రక్ట్ రెగ్యులర్ ఎక్స్ప్రెషన్ అంటారు. సో ఫస్ట్ కన్స్ట్రక్ట్ ద ట్రాన్సిషన్ డయాగ్రామ్, దాని నుంచి రెగ్యులర్ ఎక్స్ప్రెషన్ ఫైండ్ అవుట్ చేయడం. అంత కాంప్లికేటెడ్ గా అయితే అసైన్మెంట్ ఇప్పుడు నేను ఇందాక చెప్పాను చూడండి, ఎన్ఎఫ్ఏ డైరెక్ట్ కన్స్ట్రక్ట్ చేశాను. కెన్ రైట్ లైక్ దట్ అండ్ కన్వర్ట్ దట్ ఇంటూ డిఎఫ్ఏ అండ్ డిఎఫ్ఏ నుంచి రెగ్యులర్ ఎక్స్ప్రెషన్ చేయండి. అది చాలా కాంప్లికేటెడ్ రెగ్యులర్ ఎక్స్ప్రెషన్ వస్తుంది, ఒకసారి ట్రై చేయండి. ఓకే, నాట్ యాజ్ ఇట్ ఈస్ గా అది జనరేట్ చేయదు, సమ్ కాంప్లికేటెడ్ రెగ్యులర్ ఎక్స్ప్రెషన్ వస్తుంది, జస్ట్ ట్రై ఇట్.